Hello everyone. Today we will be talking about matrix multiplication. Okay. Before we start matrix multiplication, let's brush up our basics on matrices. Okay. So let's look at this matrix. 5, 7, 8, 9. Okay. So 5, 7, 8, 9. Here we can see four numbers, two rows and two columns. 2 into 2. Okay. Here we can see the number of rows and columns are equal. So the dimension of this matrix is 2 into 2, or the order of this matrix is 2 into 2. Okay, order or dimension. Okay, and let's look at this matrix. Here we can see that the order or dimension is 2 into 3. Okay, that means 2 rows and 3 columns. Okay, so let's signify. The first one is called a square matrix. The second one is called a rectangular matrix. Okay. So in the first one we can see that four elements are here: 5, 7, 8, 9. So the uh, the position of 5 is 1, 1. 1, 1 means the first one means it is located at the first row. The second one means it is located at the first column. So when you write 1, 2, here the 1 signifies that it is situated at the first row, and the 2 signifies that it is located at the second column. 2, 1, 2, 2. 2, 1 means second row, first column, and 2, 2 means second row, second column. So this is like the basic of matrices, square and rectangular matrices. And here in the position, so just for your clarity, I'll write down the positions here too: 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. So this is the our position, the rectangular matrix. Okay. When we want to add or subtract matrices, we need to be careful that their dimensions are identical. So if we want to add two matrices, if the first matrix has 2 into 2 order, it needs to be made sure that the second matrix B, it also has 2 into 2 order. Same goes for subtraction. Okay, the dimensions need to be identical for addition and subtraction. When we're talking about multiplication, it gets a little complicated. Okay, so let me talk about multiplication. Let us suppose that we have a matrix A and we have a matrix B. C equals to A into B. A here is called the pre-matrix. B here is called the post-matrix. Okay, so the rule or the precondition that needs to be satisfied before every matrix multiplication number of columns in pre-matrix equals to number of rows in post-matrix. This is the very basic and utmost important precondition that the number of columns in pre-matrix needs to be equal to the number of rows in post-matrix. Okay. So let us suppose that A has a dimension of 5 into 4. and B has a dimension of 2 into 5. Okay, so the let's look. What's the number of column in the pre-matrix? The number of column in the pre-matrix, number of columns in the pre-matrix is 4, and the number of rows in the post-matrix is 2. These two numbers are not equal, so no multiplication. You can try, but it's not possible. Okay. Okay, let's move on to another pairing. A has the dimension 5 into 4 and B has the dimension 4 into 3. Let's look at the number of columns in the first matrix, the pre-matrix, that's 4, and the number of rows in the post-matrix is also 4. Since these two numbers are equal, multiplication is possible. Okay. Okay. Since we can multiply, we will have a product matrix. This case, no product matrix. But in our second case, we will have a product matrix, and that is C. We can predict the dimension of C matrix looking at A and B. And how we'll see that? Let's look at the number of rows in A. That's 5, and the number of columns in B is 3. So the number of rows in pre-matrix is 5 and the number of columns in the post-matrix is 4. We can predict or understand that the dimension of C will be 5 into 3. If you can easily understand what the 5 came from, you can easily understand what the 3 came from. The rows came from pre-matrix and the columns came from the post-matrix. This is a very important it's a good helper. You will see why this knowledge that the rows come from the pre-matrix and the columns come from the post-matrix. This is a helpful bit of information that you will see just a bit later. Okay, so let's just look at two matrices that we can multiply. Okay, before we multiply any matrix, it's a wise thing to write down their dimensions beforehand. Okay, so the dimension of the first or the pre-matrix, let's not say first or second, let's say pre-matrix. The dimension of the pre-matrix is 2 into 2 and the dimension of the post-matrix is 2 into 3. Okay, what's most important is that these two numbers are equal. That is, number of columns in the pre-matrix equals to number of rows in the post-matrix. This is the condition that we need to maintain, or this is the rule that we need to think about. Why we need to think about this rule will be very clear once we start our multiplication. Okay. This is another quiz. Before start the multiplication, what will be the dimension of the product matrix? Dimension of product matrix. The dimension of the product matrix is 2 into 3. Where did the 2 come from? This number of rows came from the pre-matrix, and the number of columns came from the post-matrix. Okay. Okay. Before we start the multiplication, let's just think about the matrices separately. So in the first matrix, that is the pre-matrix, we can see that the first row is 5, 7, right? So how many elements are in the first row? 2. Let's write the number of elements in the first row equals to 2. In the pre-matrix, obviously, remember the pre-matrix. Okay. What is the number of elements in the second row? That's also equal to 2. Okay. And what is the number of columns in the first pre-matrix? That's also equals to 2. So if we haven't, if we say it out explicitly, but we do understand that the number of columns means the number of elements in each and every row of the matrix. Okay. Let's talk a little bit about a post matrix. Same thing. Number of elements in each column equals to 2. So we can see the first column 2, 6, 2 elements, 9, 2, second row, second column 9, 2, 2 elements, third column 8, 1, 2 elements. Number of elements in each column equals to 2. And what is the number of rows? Number of rows is also equal to 2. So we can also say that the number of rows means the number of elements in each column. Okay, let's just copy this before we move on. Okay, let's now, since we have all analyzed all the information, sorry for the little delay. So since we have analyzed all the information, let's start our multiplication. Okay, so as we have already predicted, the the product matrix should have a dimension of 2 into 3. Okay, we predicted that using the dimension of the pre and post matrix. Okay, so let's write our matrix as is 2 into 3. Let's write a PT. 2 into 3 is a rectangular matrix, obviously, so let's write it in a rectangular shape. Okay, so if we have a rectangular matrix that has 2 into 3 dimension, we can guess that the number of elements should be 1, 1. The position equals to 1, 1. It should be 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. These are not the elements, this is the position of the elements. Okay, if anyone's confused. Okay. Let's start our multiplication. 1, 1. As I said previously, we'll take the rows from the pre-matrix and the columns for the post matrix. 1, 1. First row, first column. First row from pre-matrix, first column from post matrix. Okay, so we'll be selecting the first row and first column for pre-matrix and first row from pre-matrix and first column from post matrix. So 5 into 2 plus 7 into 6. So what did I do? I multiplied the first element with the first element, second element with second element. First element 5 with 2, second element 7 with 6. Okay. Suppose that our dimension was 2 into 3 here. When I write 2 into 3, there should be another row here. Let's imagine a row, I guess like 8, 10. If I had 8 here, what would I multiply it with? I can't multiply it with. I don't have any third element in the post matrix to multiply it with. That means this is why the number of columns in the first matrix needs to be equal to the number of rows in the second matrix, or even simplified, number of elements in rows of pre-matrix equals to number of elements in columns of pre-matrix. And we just saw that a few minutes ago, that number of elements in each column is number of rows, and number of elements in each row equals to number of columns. So this is where the precondition needs to be maintained. If we do not maintain the precondition, we'll have a new element that we do not have anything to multiply with. For example, this 8, we have a third element in the first row, but there is no third element in the first column. So we cannot multiply it, and then the matrix multiplication fails to occur. Okay, so okay, anyways, let's remove the first this imaginary row and this imaginary dimension. Okay, let's continue on. 5 into 2. Okay, then again 5 into 9 plus 7 into 2, and then again 5 into 8 plus 7 into 1. Okay, this also happened. Okay, then 2 into 2 plus, you understand what I'm doing, right? I'm just multiplying. uh, yeah, okay, I'm just let me visualize this one with you guys. Okay, 2 1. What does 2 1 mean? 2 1 means second row, first column. Okay, now as we are in the second row, what does, when I say row of product matrix, you have to understand that that row comes from the pre-matrix. Okay, so, and when I say 2 1, the first column, when I say first column, I mean the first column from the post matrix. Okay, so as I have the first as I have the second row 2 4, and I have the first column 2 1, 2 into 2, 4 into 4. First element multiplication 2 into 2, second element multiplication 4 into 6. Okay, let's carry on. 2 2, second row, second column 2 into 9, and then second element into second element 4 into 2. Same, 2 into 8 plus 4 into 1. You can always see, whenever I select a pair of rows and columns, I always multiply first element with first element, second element with second element. As we have a third element, we didn't need to discuss about it, but you can follow what, you can understand what will happen. Anyways, let's write the our result. 52, 59, 47, 28, 26. So this is our product matrix, and we can also observe here that the dimension is 2 into 3. It happened so you can easily follow. So now, we just understand why our precondition is to be maintained. Because if we do not maintain the precondition, we will face a case where we have an element, but we have an element in the pre-matrix, or we have a element in post-matrix that does not have another element to be multiplied with. So, okay, so this is our lesson on matrix multiplication. This is Mahmoud Wasif Nafi from Kuwait BME. Thank you for attending my class.